Okay, I hope you had a good break. So if we continue on with this, I just wanted to show you that I added to the side there. That method 2 is really about using that addition property of equality. Okay. Actually, I'll be honest, I videotaped showing you example 1 here and realized, nah, I really wasn't recording myself, so I'm going to go over this with you. If we were asked to solve this quadratic, it's already got the first step kind of done for us, right? That if we can kick that out, because although it's a good perfect square there, it's not the perfect square trinomial here, right? So our strategy is going to be, well, if I split the 10x along here, what is it that I'm going to add to make it perfect? And that would be 25. But now I'm going to add it to both sides of the equal sign. Right? Why? So that I can express this part as perfect square. Combine these two. Now I'm just going to square root both sides, right? And I would wind up getting a positive or negative 3. Please don't forget both, because remember, we can have 1, 2, or no solutions to quadratics, right? So this one's going to have 2 solutions. I'm going to solve it both ways, where x is 3 and x is negative 3. We'll subtract 5 from both sides, and our solutions will be negative 2 and negative 8. I'm going to write it in set notation like that, meaning these are the 2 roots or intercepts, right? Solutions. I could also write them in ordered pairs if I wanted to, right? Okay, let's turn your paper over and try this example. So not in standard form. You know, if it was in standard form, we would want it to equal 0. We'd move it back over here. But if we want to use this method of completing the square, well, then we're going to just take 3 away from both sides. Okay. So then I can make room to add whatever it is that's going to make this a perfect square trinomial, right? So x squared plus 14x stays there. Leave a little gap, and we're going to get 12 over here, right? So, you know, a lot of the videos that you've been maybe watching have not, you know, used that area model. You can still do that, where we split this, divide it by 2 along the diagonal of the square, right? And so we would get 7. And then when we square that, what are we going to be adding? I'm going to add 49. Not immediately subtract it, because it's not an expression, now it's an equation. I'm going to use that addition property of equality. If I add it to the left side of the equal sign, I'm going to add it to the right side of the equal sign. Okay. Okay, why do it? This is now expressed as x plus 7 squared, and it equals 61. Okay. If we do the square root, well, 61 is not a nice perfect square, unfortunately. So we'll find the positive square root, and we'll find the negative square root that it could equal. Now, I should see if I can simplify this, but I know there's no perfect squares, because that's a prime number, right? So it doesn't have any perfect square factors. I am just going to use the decimal approximation. Now, whatever worksheet or practice you're doing will tell you what they want. Do they want you to simplify it, or do they want you to approximate it, all right? So the approximation of the square root of 61 to the nearest tenth is 7.8, or negative 7.8. Right? So if I go through for solving and subtract 7, got my 2 different equations to solve, right? X equals 0.8, might do a little 0 in there, or x equals negative 14.8. Again, in set notation, my preference is to put them in greatest to least order. Okay, hopefully that makes sense. If not, make sure you're getting in contact with me, okay?